Hello everyone, welcome to Codecrafters Lab. So today we are going to see a new problem, that is second largest element. So we have given an array of integer nums and we have to return the second largest element in the array, and if the second largest element does not exist, return -1. So here in this example you can see there are 5 elements in the array: 8, 8, 7, 6, 5. So the largest element is 8 and the second largest is 7, so output is 7. And there is one more example, that is 7, 7, 2, 2, 10, 10, 10. So which one is the second largest? So 10 is the largest, 7 is the second largest. So let's select and validate. So yeah, that's correct. So how to solve this particular problem? Okay, we can take one example. Let's say which one, that nums equal to the first one, maybe we can take nums equal to 8, 8, 7, 6, 5. Okay, so basically, yeah, so this is the example. So what we can do here is the first approach is a brute force approach. So in brute force approach, what we do generally, we try to scan the entire array manually also, and we find the largest element. So here we can see 8 is the largest, and then we see which one is the closest to it and which is lower, right? So that is 7. So this is how we generally find the second largest. So same way we can try to find the second largest element in the brute force approach. So what we can do is, like, let's say we can take one element in n equal to nums dot length. So it will give you the length of the array. Then what we'll do, int, if let's say if n is less than 2, if n is less than 2, in that case what we'll do, we'll return -1. If length is less than 2, that means only one element is present in the in basically the our array, right? Then what we'll do, we'll sort the array, arrays dot sort nums, right? So it will sort the array. Then what we'll do, we'll find the largest element is the basically the nth element, right? The last element is the largest element. So how you can say, int largest element equal to nums of n minus 1. So this is the largest element, right? Then what we'll do, we have to find the second largest, right? So second largest can be anywhere, right? So we saw in the example, if we sort this array, it will look like something like this: 5, 6, 7, 8, 8, right? So this is the largest element. So we can't directly say that the number below the largest one is the second highest, because we have to validate that, because there can be an instance where multiple highest elements can be there, right? So what we'll do is, like, we'll do the iteration for int I equal to n minus 2, I is greater than equal to 0, and I minus minus, right? I minus minus, right? So after this what we'll do is, like, we'll validate if nums of I not equal to largest, second largest equal to nums of I, and break, close, will close, and will return second largest. Okay, so basically in this way we are handling that condition where multiple largest element can be part of that particular array. So let's try to code this one. So what we'll do is like int n equal to nums dot length, right? Then what we'll do is like if n is less than 2, then what we'll do, we'll return -1, return -1. That means there is only one element in the array. Then what we'll do, arrays dot sort of nums. Okay, so we have sorted. Then for int I equal to n minus 2, means we'll start with the second last element in the array and we'll traverse it in a reverse order, right? I is greater than equal to 0, I minus minus. Then what will search, if nums of I not equal to is not equal to the largest element, which is nums of n minus 1, right? If it's not equal to, then int second largest equal to nums of I and break, right? And break, maybe what we'll do, yeah, let's keep it that way, and we'll return second largest on this. Return, okay, sorry, I guess we should declare this outside largest and not have been initialized. Okay, you have to initialize the number and it is passed, and this is not okay. So we haven't handled one condition here, which is if there is a single element, the same element is part of the entire array. So in that way, in that case, it will fail, right? So in this case it is passing, but in this case it is failing because not 0, we don't have to initialize it. So what we'll do here is like we'll declare this one as -1. Okay, -1. Yeah, so all the cases are passing in this particular example. Now let's talk about the space complexity and time complexity. It is nothing but the space complexity. Space complexity is O of 1 because we are not doing like any storage or something, and time complexity is nothing but O of n log n because we are sorting the array, right? So yeah, in the next lecture we'll see the better approach, and maybe afterwards the optimal approach for this particular problem. Thank you for watching.